Now we are recording. Now we are recording. Okay, so with I just stuck this here because it will make our lives easier when now going through the question. So here you can see the first scenario they're saying the dairy ice cream factory uses a filling machine, all right, for its 2-liter cartons, okay? 2-liter cartons. There is some variation in the actual amount that goes into the carton. The machine can go out of setting, okay, and inject a mean quantity less than or more than 2 liters, okay? To monitor the filling process, the production manager selected a simple random sample of 46 filled cartons and measures the contents. The average amount per carton was found to be 2.15 liters, okay, with a standard deviation of 0.30 liters. Test whether the machine is still in setting using a 5% level of confidence or significance, okay? 5% level of significance. Okay, so remember step number 1, we need to determine our statistical hypothesis. Okay, so what do we know about our situation here? We know that if we're to actually say either X, right? In other words, the mean of our cartons is equals to 2 liters, which is what we want it to be, or it not equal to 2 liters. Let me do this. Right? Those are our possibilities. Now, we obviously need to set up H1 and H0. So, which one is going to be H1 there, and which one is going to be H0? The equal to is H0, okay? So another way we could do this, sorry, we're basically saying, okay, that's the mean of the population, okay? So yeah, then we can just quickly say H0 is then, and then H1, let me do that in orange, is then obviously that one there. So step number 1 is dealt with, then we go to step number 2. And that's where we determine our region of acceptance. Can you see? Sometimes they say region of acceptance, sometimes they say region of rejection. Okay. Yeah. Okay, but the whole principle is the same. What we are looking for is to say, what is our decision rule? When are we rejecting and accepting our nil hypothesis? Okay, so what type of test is this? We can either have cartons that have a mean greater than 2 liters and less than. So what type of test would this be? One-sided. But is there only potential for one outcome where we would reject? Remember, we can either have more than 2 liters or less than, isn't it? Yes, but isn't here we're now deciphering? Yeah, yeah. Sorry, say that again. Yes. You're actually stating the case here for 2-sided. Can you hear yourself?
Yes, that's what I
Oh, I thought you said initially you said once, isn't it one-sided? You know, it is two-sided, I agree. So maybe I'm mishearing you. My apologies. I thought, I know you said one-sided initially. Oh, no, no, no. I said it's either equal to or not equal to. So, yeah. So that's 100% it. Okay, I don't need to draw this actually because you guys get it. So we then say, okay, at a 5% level of significance, all right? So in other words, your alpha is equals to 5%. And again, it's two-sided. Eesh, what am I writing here? Okay, so we then go now to that slide that we had before. Where is it? There we go. And I'll show you the slide I'm talking about, this one here, to determine the z limits. Okay, so we know we're doing a two-sided and we're doing it on 5%. So here you can see plus minus 1.96. So basically, yes. No, this is, sorry, yes, let me hear. I'm saying that slide. Is it just an example, or are we going to also use that information? We always use this information. Yeah, you know, it's not an example. It's these are the Z limits that we always use. It's now just obviously depending on our level of significance. Am I answering your question? Meaning that this will be the same exactly. We need to, I actually meant to double check that to look at one of your past exams, but I imagine that it should be because I don't imagine that they are expecting you guys to cram this because it will always be these values. So when I looked at the back of your workbook, I didn't see them. But when, you know, if we look at the, what do you call it? The past test paper, I mentioned to do that. That should tell us whether they're provided or not. But I think they should be, if you ask me. That one, eh? Hey, yeah. So here you can see this is where we're now talking about our, let me do it in green. Why? What is the? Fish thing? Which? Oh, this, yes. Oh, yes, this is alpha. This is alpha. Fish thing, yo. Okay. Right. So here we're basically, remember this is your region of rejection, isn't? So we're basically saying, here if we had a plus and a minus of 1.96, isn't, from the table. So we're basically saying here, if our mean is we want it to be within these regions, okay, less than, it should be less than 1.96. And sorry. I'm confusing myself here. The Z statistic. Sorry. So our Z stat, okay, it should be greater than 96, and it should be, if it is less than 1.96, 0.96. This is the same thing. Then we are going to do what? What are we going to do? Then we're going to reject. Okay? Because if yeah, then we're going to reject the nil hypothesis. And the claim is it falls within the sorry? I did not hear. Okay, so I was just saying if the score that we get in step number 3, because number 3 is where we actually run our test, isn't it? Where we calculate our sample, all right, Z statistic, okay? If that result is greater than a positive 1.96, we are going to reject. And if it is less than a negative 1.96, both of these we are rejecting. Okay, we're rejecting the nil hypothesis. Okay, so now in step number 3, that's where we now do the calculation. Okay, so step number 3, the formula we're going to use, let me change this to blue. Z. You're going to see this is quite familiar. Is equals to x minus divided by, okay. So here, you guys remember this from learning unit 7, isn't it? And here, the average that we got from the sample was 2.15. Okay, and the average of the population of these cartons should be 2, isn't it? Okay, and then we know that S is the sample, sorry, the S is your standard deviation. Okay, so actually, this should actually, I think, maybe I mixed it up, but this could actually very well be your, I put an S there, but we could also do this. Okay, so here we're saying 0.3 divided by N was what? What was the sample? 46. Okay. And the way we are behind. Never. But okay, so these calculations they are not foreign to us. So that's why Q is standard deviation. Yes. Yes. Yeah, we're calculating SE there. All of this is your SE, standard error. Yes. Okay, so I'm just in the interest, we've done this calculation, so I'm not going to spend time here. Okay, but what you should get then is 3.39165. Okay. Yeah, please, by all means, you can calculate that if you want. So you don't have to do both you could do that because that's the habit we've built in learning unit 7. You could do that. I would prefer to do that first. Yes? The answer is correct. Okay, we're aligned. Okay. So now remember, step number 4 is simply to compare. Right? compare what we have calculated, the results of our experiment, basically, with our decision rule. So we said, can you see here? We said if the Z statistic is greater than 1.96, we're rejecting. And if it's less than negative 1.96, we are still rejecting. Okay? So here, if we look, 3.39, is it greater than 1 point, a positive 1.96? Is it greater than? So what are we doing? We're rejecting. Okay, so we're rejecting. H0. Yes.
So this is the two-sided.
This is the two-sided. 100%. It's the two-sided.
So as soon as we say equal to, it's accepted.
Sorry?
If it says more than or less than equal to, like there's a negative on the.
Yes.
Is it accepted?
You mean this, right?
Yes.
The moment you see plus minus 1.96, what are you saying? No. We're just deciding on our decision rule. When do we reject? When do we accept? So if, for instance, let's just say for argument's sake, we had gotten our Z statistic to be, let's say, 1.05, what would we have done? When comparing it, we would have compared it with this positive 1.96. So what would we have done? We see that our result is given as 1.05, and we said our rule is if it is greater than 1.96, then what must happen? We reject if it's greater than. But what is this? Is it greater than? It's less than. So what would we do in this instance? No, we would accept the null hypothesis. We would accept. In this case, this one here, we would accept. So we would basically say we are accepting that the cartons are 2 liters. Okay. In fact, let me finish this step, then I'll take you to the conclusion, because right now I'm actually taking you to the management conclusion.
So what would you do if the null hypothesis is greater than or equal to? That's what I'm saying.
Oh, no, we will get to that. We'll get to that with these. Yeah, we're still getting to that. Okay, right. So, yes, so here we said we're rejecting. So we're basically saying we reject that at a 5% level of confidence, the null hypothesis. And the null hypothesis was saying that our cartons. See, you guys are making me do all this. See what you put me through. Mm-hmm.
So it's just 2 and the different.
And the difference.
So it's 23 and 3 different scripts was 26.
Oh, okay.
No, she said.
Oh, okay. Yeah. But I don't think we marked the deferred. I don't think I marked for stats.
Let me see.
I have those ones. I think there are 3 of
Which one
them.
is this one?
Maybe it's test 1.
Oh, it's group 2, sorry. It's not deferred. It's a smaller group. It's group
Oh.
2 students.
Oh, okay.
Sorry.
No, it's fine.
Sharp.
Sharp.
Oh, date.
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 Today is the 16th, huh? No, we'll collect after the session, eh? So that we can finish here. You must take it. If you want to burn it, it's fine, but it's yours. It's not mine, it's yours. I didn't write that thing. All right. So we're saying at a 5% level of confidence, we are rejecting the null hypothesis. Okay? At a 5% level of confidence, we're rejecting the null hypothesis. Okay? So it's basically saying we are rejecting the assumption connected to the nil hypothesis. And remember, what was our nil hypothesis? Here we said our nil hypothesis is that the average, or in other words, our containers of milk are 2 liters. Can you see? We said is equals to 2 liters. So we're saying no, our containers are not actually equal to 2 liters. Can you see that? All right, is it making sense? Wow. This part should make sense. The challenging part is getting the step number 1, getting your decision rule. If you can get those 2, here we've done this, so we're happy with this. And then obviously interpretation is just if we're rejecting the nil hypothesis, because remember our test is on the nil hypothesis, that means whatever assumption is coming with the nil hypothesis, we're rejecting it. What assumption did we make with the nil hypothesis? We said that our containers are equal to 2 liters. So if we're rejecting that assumption, we're saying no, they're not. Does that make sense? At a confidence level of 5%. The reason why we're saying that is when you say at a confidence level, it means I am 95% confident that whatever conclusion we arrive at, it is correct. Because remember, there's always room that we made an error or our findings are not actually correct. Does that make sense? So whenever we talk about level of significance or confidence level, we are just talking to the fact of how confident are we in our test or our results. Does that make sense? So the 5%, we're saying there's a 5% chance that we are wrong, which means there's a 95% chance that our results are wrong. Makes sense? Good question. Good question. Okay. Right. So let's see if we can squeeze in. No, I'm lying. Okay. So here, I'll just discuss the answers. Guys, go and do revision exercise 3. Okay. I see we literally, oh, my watch is ahead.
7.
This-
8.
Mhm.
We're done at 7.
I knew it was coming. That's why I kept quiet. Revision exercise 3. In fact, let me just say this. We'll just discuss even revision exercise 3. What you guys need to go and do, you need to go and revise this learning unit, go through the examples, and then go back to these revision exercises and do them again.
So those examples on the slide.
Yes, on the slides.
From slide.
Those examples on the slide.
31 to
7. I don't think I send them to either. I'll send them. I think from the test, I haven't sent those yet. So I'll send for both groups. From what? So that's 6, 7, and 8 I need to upload. Then 9 I will upload after we do. Yeah, we're done today. With
Yeah.
yes. I don't know. You must tell me. You must tell me what's wrong with these people. Hmm? So with this situation, they're saying a health and safety inspector randomly sampled 200 reports. So sample size is 200. On industry accidents. Okay, so what we're looking at is industry accidents. Okay, and found 53 were due to untidy working conditions. Okay, then it goes on to tell us that a factory manager claims that less than 20% of accidents are the result of untidy working conditions. Perform a hypothesis test at a 10% level of significance, okay, in order to determine whether the manager's claim is true. Okay, so From our sample, we see that, or you can, yeah, is equals to 53, right? And we also see your fish is 10%. Okay. So to get the population, all right, of the sample, we then are basically saying 53 divided by 200 to get a population of, remember hat is for the sample, isn't it? So that would then give us what? What do you guys get when you punch that in? Okay. Then, but this manager is saying that, hey, no, our population is equals to 20%, which is 0.20. Okay. So is the set is less than, okay.
So,
Yes.
then the 53 over 200 is the sample.
Is the sample population. You can call that sample population. Yeah, this
10% for what is it called again?
level of significance.
Level of significance.
Yeah. Sometimes we also call it
Confidence.
confidence level. Yeah. Hmm. Okay. So then now what we are saying is, okay, we are basically asking ourselves, is these accidents, are accidents, 20% of accidents, are they caused by an untidy working condition, or is it going to be more than? Okay, so it's two situations. X can either be less than, less than 20%. All right, or it's going to be, X is going to be greater than, equal to or greater than, because remember I said less than, right? So the claim is that it's less than, isn't it? Let's go back to the question. Maybe I'm also, less than 20%, isn't it? So this is the claim. Can you see that? And then we are saying, but the claim could be wrong. If the claim is wrong, that means that it is either equal to 20% or greater than 20%. So we then have to ask ourselves, okay, can you see we have our assumptions? I think it's easier to approach it this way, to say, what are the assumptions that we can have where our claim is true or our claim is false? Then you say, okay, so which one here is going to be H1 and which one is going to be H0? Which one is going to be our nil hypothesis and which one is going to be our alternative hypothesis?
No, the second one.
The second one is 80.
You guys all agree?
Yes.
Are you sure?
Yes.
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 They all have hypotheses.
The H1 is the one with the equal sign.
You are so right.
Ah, sure. You said.
Yes,
Sir.
H1 is the one with the equal sign.
No. So you said 80 was the one with the equal.
Oh, wait.
So you said 80 is the one with the equal.
Wait, guys, pause. 2 seconds, 2
So you
seconds.
said H1 never has.
No.
That's the
I'm
one.
not disagreeing. I'm just saying, give me a second to speak. That's all I'm saying. 100% right. The reason why I was saying no is because I was basically pretending like I'm disagreeing with what you guys initially said. Does that make sense?
No.
So there's no time for playing around.
Okay.
Okay, so we need to 80 is
Nil hypothesis.
80 always has the equal sign. Okay? So which means that 80 is this one.
the second one.
Yes. Okay. Sorry guys, I was having sorry.
So not fun without you.
So yeah, I see they use pi, right? Yes. All right.
Wait, it's not like they don't have the same formula.
No.
Why? Wait,
It's-
so if you look at these stats and now this X.
Remember, we use one. We have two things that we are usually testing. It's either mean or it's population. So can you see? That's why we're using this. Can you see? Remember, even in unit 7, we were doing this wherever we had population. Guys are treating me like I'm just bringing things from the sky. Remember, so you have to interpret. No. But think about it like this. Here we were saying 20% of accidents. And you see, we're talking about the population. What is the population of accidents that are caused by untidiness? Can you see? So it has to be deciphered in the question. Okay. But if you can at least get your things here right, I think I won't be.
Hey, why not?
Huh?
So what are they using pi for?
It's population. So we're saying 20% of our accidents are, and sorry, less than 20% are caused by untidy. All right. Okay, you even see here in their answers, that's what they did. Can you see? Step number 1. So now again, we have to ask ourselves, area of acceptance and rejection. Can you see here? We will reject. What was our level of confidence? Sorry, I'm jumping.
0.1.
0 point? Yes, 0.1, which is 10%. It's fine. So we go back to our So where's our slide?
So we just did step 1, right?
Yeah, we only did step 1.
Okay.
We only just yes. Let me double check.
So now we determine region of acceptance.
Yes.
Okay.
Oof. It is definitely a one-sided. Yeah.
Oh, yeah.
One-sided lower. The lower answer is the lower.
What is it?
So it's give us a second.
Mm-hmm.
Yeah. The lower tail, one-sided lower
Minus 1.6.
Yeah, you are right. It is one-sided lower tail, and we are here, isn't? We're at 10% or 0.1. So it's this 1.28. So
So if it's negative, does it go with its sign?
yes, it actually does. So you got your Z. Let me change color. Ba, ba, ba,
So
ba,
they
ba.
also give us that table in the question, I mean in the exam, right? Like the one side.
I have to confirm. I meant to check before even the lecture. I never checked.
So there's no way those values are.
That's exactly what I was telling the guys earlier. That I assume that because they don't change, you see. And what's the value add of you cramming those numbers? It doesn't, you know what I mean? So for me,
They have to give us that. It's like this huge distribution thing. They
Yeah.
have to give us that.
yes, no, that one is a given. That one we know for certain they're giving you guys. Okay, so we're saying if it is our results is less than negative 1.28, then we are rejecting H0. Okay, so again, guys, I said I'm discussing the answers here. So you can see here they're doing population, isn't? And you know this formula is not brand new. We've seen it before. So here you can see we have our answer is 2.3. Is
Yeah, so go to step 2, please.
yeah.
point where we reject H1?
No, we always do it in terms of H0. But by virtue of accepting H0, we are rejecting H1. And by virtue of rejecting H0, we are accepting H1. Because remember, it's the opposite. But yeah, when you guys interpret, you have to do it in terms of H0. Because that's what we do in statistics. We are always conducting our experiments based on H0. Okay, otherwise, you are going to. So step number 3 was the actual calculation. It's step number 4 where we are comparing. And here you can see that our Z statistic was greater than 2.30 is greater than 1 and then a negative 1.28. Okay, so we are not rejecting. In other words, we are accepting H0. Okay, so here you can even see now what is the conclusion. If we are accepting H0, remember what I said earlier, by accepting H0, we are saying we agree with the assumption of H0. And H0, what did we say? We said it is the one with the equal sign. We're saying it's greater than or equal to 20%. So we're saying that our accidents that are a result of an untidy working place, we have more than 20% accidents that are happening in this industry as a result of untidy working conditions. It's making sense?
Yes.
Your face though. Your face though. It's not it's not make sure. So guys, when it comes to stats, always you have to just refer back to what am I actually testing for? What have I actually, what is my premise? Does that make sense? And if you don't understand your premise, then you can't conclude. You can't interpret. Isn't it? Okay. I'm looking at time. I see we are actually over, né? So we won't even get a chance to discuss question revision exercise 3. But with this one, they only had 3 revision exercises. So again, I'm going to repeat. Your challenge here or your work is interpreting what are the assumptions. Then which one is H0? Which one is H1? Okay, and like we established, H0 is always going to have the equal sign. All right, because someone was saying I'm playing with their futures. So let me make sure.
And in the exam, I put equals to for H1. So, so please don't do that.
Okay. So any questions? Any thoughts?
Right?
So yeah, let's leave it there. Yes, we're not. We're accepting it. We're accepting it.
What's the conclusion, sir?
Okay. So here, step number 5 is your conclusion. So you'll find instances, they'll either say we do not reject, or they will say we accept. H1, H0, sorry. And here you can see at a level of significance of 10%. This is also important because remember, we could have ran our test at a 1% level of significance or a 5%. And if we ran it at those level of significance, we very well might have a different answer. Does that make sense? So it's important to also include that in your interpretation or conclusion.
So can you go to the
My class monitor.
So can you go to the calculation step?
Yeah, sure. You can come and start collecting your things over there. Let me just kill this here.